I'm going to explain about your process control laboratory, and our subject code is CH8711 and process control laboratory. And first of all, the procedure for all the experiment is what same, because we are going to use SCADA software, so that we are going to use the same procedure, the slight modification. So let me explain what are the steps to be followed to start the experiment. Let us say step 1, there is a SCADA icon. You have to click SCADA icon. Window 1 will be open. In the window 1, we can see the what two uh, menu, open process and configuration. And then you have to click open process. And when you click open process, that is step 2, open process, window 2 will be open. In window 2, you can see different process name: temperature control, flow control, level control, pressure control, and cascade control. So within single software, we can able to control the different parameters. So now I'm going to explain how to control the pressure system. So here I'm going to choose pressure control. Just you have to click a pressure. See that the third step is the pressure process I'm going to select. When I select the process, pressure process, third window will be open. Third window, it's very important one. This is what your actual window where open process configuration and about the software is there. It's L. And here, since our pressure is, our process is pressure process, and below that we have the different menu. It's very important. Start logging, stop logging, PID, history. Below that you have the process variable, set variable, and control variable. In that, first step is what you have to do is, before you're going to start any process, first you have to choose the PID value. See that? That is what your fourth step. Window 4, and you have to provide the P value, proportional value, integral value, derivative value if the process is what PID controller. If it is proportional controller, you have to provide only proportional value, and the integral value is 0, differential value is 0. Here we are going to use proportional integral derivative controller, so that you have to provide proportional value is 0.1 and integral value is 0.2 and derivative value is 4. It means that you are going to control your process using PID controller. Okay, and then within this window we can able to set whether it is a closed loop, open loop, or on off control. Okay, here if you want to use the pressure control, if you want to control the pressure as a closed loop control, just you have to click the set in the window 4. It will show the menu like this: closed, open, and offset. So since our process is closed loop, so that you have to click the close. Okay, and then you have to give the value of proportional controller, integral, and derivative. And then here you have the one more menu is there, auto tune. When you click it, okay, that SCADA will automatically tune the value, tune the proportional integral derivative, and it will set the automatic value of proportional integral derivative. And then this step, first step is over, and then second step is your set value, desired value. Okay, to what percentage you are going to control it. So when you click at the set value, okay, another window will be open. You have to give what is your desired value. For example, my pressures to be controlled at 10 bar. I have to click 10 bar here. And then third step is, once I set the value, third step is I have to click the start logging. Immediately you can see the graph like this. Okay, the graph starts to plot from 0. Y-axis, the x-axis what time, and y-axis what pressure, that is process variable, that is your bar which is pressure maintained in a tank, and this is what your set value. So this process variable starts to what rise from 0, and it will reach the set point. Once it reaches the set point, you can click the stop logging. Okay, your process is over now. Then you have to get the value from this window, right? For that, see that, move to the step, move to the step, stop logging, and then ninth step is what? History. Okay, when you click the history, you will get a window 5 and move on to the window 5. This is what window 5, where you can see the export chart, print, and Excel. That value can be what? You can get it in a form of chart. You can directly take a printout, or you can get an Excel sheet. So here we are going to get an experimental value in the form of Excel sheet, so that you have to click the Excel icon here. And once you click it, what will happen? Whatever the data, it will be what uploaded in a Excel sheet that you have to store it. When you open the Excel sheet, you can see the value like this: time in a x-axis and process variable in your y-axis. Once you got this value, x and y value, next step is you have to go for your calculation part, where you have to plot the graph between process variable and then time. Your ultimate aim is to what? Find out the time constant for this process. That is what you know. So how to find out this? We are going to use 63.2% method. Okay, it means that you have to plot the graph, and this is the maximum value is called ultimate value. For example, here your ultimate value, let us say 60 bar. Okay, first you find out what is the 63.2% of the 60 bar. Okay, so that will give you 37.92. And then so here in a y-axis, mark the value of 37.92. Okay, you have to draw the horizontal line until it intersects the your process curve, and then you draw the vertical line towards down. So here, when a vertical line intersect the horizontal line, that value is what? Your one time constant. For example, let us say here 1.8 second. So now you got your ultimate value, that is tau 1 is 1.8 second. Okay, and then for different process, you can also find out the resistance. Here the resistance for first order system is tau equal to AR. A is the time constant which is obtained from the graph. A is the area of the tank, area of the system, and R is the resistance. To find out R, okay, you have to re-modify this equation like R equal to tau by A. Tau value is what obtained from the graph, and A is what area of the system. If it is tank, okay, length into breadth. If it is cylinder, you can use a pi square by 4. With help of this, we can able to what? Resistance. So this is the general procedure for the system. That's it.